Here's our first application problem for Extrema, or our first optimization problem is what we will call them from here on out. So applying those 4 steps for an optimization problem, the first step is to get organized. Read the problem carefully and make sure you understand what is given and what is unknown. So maybe pause the video, make sure you've read through the problem, maybe take some notes or highlight some numbers that stick out to you because it's likely we'll return to those and use them. We also want to identify our objective. Remember, this can be one of 2 things, either minimize something or maximize something. Based off this problem and reading through parts A, B, and C, it's clear that we are maximizing profit. Okay, so we want to be specific about what it is we are optimizing. And this problem talks all about maximizing profit. How many cars to be produced to maximize profit? What is the company's max profit? And things like that. That next bullet says, if possible, sketch a diagram and label the various parts. So we can't really draw a picture of the company and their cars, but I do want to sketch out a diagram in this way, kind of build a framework for where we're headed in this problem. We are maximizing profit. So let's review. Profit is equal to revenue minus costs. So those will be 2 building blocks that I will use to get to my profit function. If we take a quick look at step 2, the setup, we will need to create the function to optimize. So since we are maximizing profit, we will need to create a profit function. And we'll use this building block here to get there. So I'll create a profit function, a capital P of X, which is equal to a revenue function minus a cost function. Going back up to the problem, they don't give us either a revenue function or a cost function. So we will have to construct those 2 functions as well. Let's continue building out a framework for our pieces. Revenue is equal to price times quantity. So when I'm building a revenue function, its 2 components will be price and quantity. Going back up to this problem, they do give me a price function. The sentence says the company's price function is lowercase p of x, 22,000 minus 70x. So there's my first component for my revenue function. Okay, so let's go back up and think about quantity now. What represents the quantity? X represents the quantity of cars sold. So filling in for quantity here is X. So there's my revenue function, price times quantity. As we're building these functions, always clean them up and simplify as much as possible because it'll make the work ahead of us much simpler. So let's distribute in this X to each term. Okay, there is my revenue function. Just so we don't get lost, I'm going to highlight that in green, and it stands for my revenue piece up here. So I have half of it finished. We still need to work out these costs and build my cost function. Let's go back up to the problem and think about what costs are involved to produce these cars. The first sentence says it costs $8,000 to produce each automobile. Let's just start there. So it costs $8,000 to produce each automobile. Again, what represents the number of automobiles, or the quantity? That's X. So $8,000 per car, plus the problem mentions fixed costs, rent and other expenses that do not depend on production. Those are $20,000. So I will still have to pay those $20,000 in fixed costs, and they don't depend on production, so I don't put an X next to them. There is my cost function. So I have both of my pieces for my profit function. Let's put them together, revenue minus cost. My profit function equals. I'll use green for the revenue function, minus, because the cost function has 2 terms, put up parentheses. Okay, there we have our revenue minus cost function to equal the profit function. Like I said, whenever we're creating these functions, let's go ahead and clean them up and simplify. So let's distribute this minus sign to both terms in the cost function and combine any like terms that we have. I'm going to order it so the highest exponent is up front, the minus 70x squared. Let's combine those two x terms, 22,000x minus 8,000x, for a profit function. All right, we have finished step 2. We've created the function to optimize. Remember, in step 1, we determined that our objective was to maximize profit. In step 2, we need to create the function that we're going to maximize, which is that profit function down here. So the hard part is over. Step 3 now is to optimize, or to find the critical numbers of this profit function, which is just to take the derivative, set it equal to 0, and solve for x. Let's do that quickly. There's my derivative, set it equal to 0, and solve for x. A little bit of algebra, and we see that x equals 100. Step 4, use this critical number to answer the question parts. Let's go back up and read the question parts. Part A, how many cars should be produced each week to maximize profit? Remember that x represents the number of cars, so the answer to A is easy, 100 cars. B, for what price should they be sold? If I want to know something about price, we have a price function that will tell us that. This 22,000 minus 70x is the price function. So let's plug our 100, our critical number, into the price function, and we'll find the price to sell these 100 cars, $15,000. Let's see, what is the company's max profit? I want to know something about profit, so let's use the profit function. Here is our profit function. Let's go ahead and plug 100 in for x to this function. So capital P of x. I'm running out of room here, so I'll just write the minus 20,000 right below. This will equal $680,000 for a maximum profit. And we're finished.